Okay, so notes for today are 3.5. So when you are labeling your notes, make sure you put 3.5 notes at the top. Alright, so these are our I can statements. I can write factors of a quadratic equation given the roots. I can write a quadratic equation in standard form given the roots. So a root of an equation is a value that makes the equation true. You can use the zero product property, which is what we talked about today in class, to write a quadratic function from its zeros or a quadratic equation from its roots. Roots are equivalent to what other term? If you guys remember from class, and it actually says it right here, the roots are the zeros of the function. So first activity, we've got write a non-zero linear function f of x that has a 0 at x equals 3. So a non-zero linear function. Linear function means that we just have an x, right? No x squared. X squared is called quadratic. So we're basically doing the opposite of what we did in class. So if my 0 is x equals 3, we're working backwards from x equals 3. Okay? So we're actually going to take the 3 and we're moving it back to the other side. If you were not here today, we ended up with factors, if you guys remember doing the factors. So say we had factors of x minus 3 and x minus 4. In class, we were setting each of these equal to 0 and then solving for x. So now we're doing the opposite of that. So we've got x is equal to 3, so we want to move to the 3 to the opposite side. So we're actually going to subtract the 3 to move it back over. So we have x minus 3 equals 0. And that is actually the simplest linear function. It's just going to be, I don't really have a whole lot of room for this. So for letter A, it's f of x is equal to x minus 3. That's the simplest linear function where we have a 0 at 3. So letter B is going to be very similar to that. For B, we have a non-zero g of x that is at x equals 4. So starting with x equals 4, I'm working backwards here, so I'm subtracting the 4 from both sides. I end up with the x minus 4 is equal to 0. So the simplest linear function, where we have a 0 at 4, is going to be g of x equals x minus 4. Okay, and then for the second part, number 2, for f and g from exercise 1, write the product function h of x equals f of x times g of x. So all we're doing is we are taking the two functions that we found, and let me do that in a different color. We found x minus 3 and we found x minus 4 to be our two functions, and we are multiplying them. Okay, it wants us to take f of x times g of x, so x minus 3 times x minus 4. And I am going to erase this so that we have room. So our two functions were x minus 3 and x minus 4. So I am going to multiply these using FOIL. So for FOIL, that's first, outer, inner, last. We start with the first terms, x and x. X times x gives me x squared. My outer terms are x and negative 4. So x times negative 4 gives me negative 4x. My inner terms, negative 3 and x. So negative 3 times x is negative 3x. And then finally my last terms, negative 3 and negative 4. So multiplying those, I get a positive 12. And then I simplify, so x squared minus 7x plus 12. And that's just by combining these two middle terms. So for letter A, number 2, it says to multiply these two, the f of x and the g of x, and I did it. Okay? So my new equation, h of x is equal to x squared minus 7x plus 12. For letter B, what kind of function is h of x? So this should be kind of obvious because we've been working on these exact functions for several weeks now. Anytime we see an x squared, and this is the highest exponent, that is going to be a quadratic function. And this is in standard form. So my quadratic function is, my answer is quadratic function. So what kind of function is it? It's a quadratic. And letter C, solve the equation h of x equals 0. So it wants us to take my equation and do what we did in class today. X squared minus 7x plus 12 equals 0. So using the zero product property, we are writing our two binomials. The binomials were x minus 3 and x minus 4. To write the binomials, we're just trying to find the two numbers that add to give us negative 7, but multiply to give us 12. And that's these two, negative 3 and negative 4. And then we set them equal to 0. So this is just showing us how to do this both ways, working backwards with the roots, from the roots working toward getting the quadratic, and now doing it the other way around, from the quadratic getting our roots. So x minus 3 is equal to 0, which means x is 3, and x minus 4 equals 0, which means x is equal to 4. Okay, so these are going to be a few practice problems, practicing what we were just talking about. We're trying to write the quadratic equation. So working backwards here, I have number 3 says 5 and 3. So that means I have an x equals 5 and I have an x is equal to 3. So working backwards again, changing this by subtracting the 5. So x minus 5 is equal to 0. This is our first one. The second one, subtracting the 3. So x minus 3 is equal to 0. And then to write the quadratic equation, I just do exactly what I did on the previous slide. I'm taking x minus 5 and I'm multiplying it by x minus 3. This is the opposite of what we did in class today. Okay, so using FOIL again, x times x is x squared. X times negative 3, negative 3x. My inner terms, negative 5 times x, negative 5x. And negative 5 times negative 3 is positive 15. And then I just combine my two middle. X squared minus 8x plus 15. And this is the quadratic equation in standard form. Okay, for the next one, for number 4, this one has a decimal in it. So for this one, I've got x is equal to 2.5 and x is equal to 4. So again, working backwards, subtracting my 2.5 from both sides. And for the second one, I'm subtracting 4 from both sides. So my first one is x minus 2.5 equals 0. My second one, x minus 4 is equal to 0. And I'm taking these two and multiplying the factors. So x minus 2.5 times x minus 4. So again, I am using FOIL. My first terms, x times x. My outer terms, x times negative 4. My inner terms, negative 2.5 times x. And then my last terms, negative 2.5 times negative 4, which is going to give us a positive 10. So then combining my middle terms, I get x squared minus 6.5x plus 10 equals 0. And then finally my last one, and I'm going to delete the one on the left side so I can make some space. And actually it's not going to let me delete it, so I'm going to have to delete all of this. Okay, so I am looking at the third problem here, negative 4 and 4. So x is equal to negative 4 and x is equal to positive 4. So I start by moving whatever number's on the right side over to the left side. So for this one, I'm adding 4 to both sides. So I get x plus 4 is equal to 0. For the second one, it's a positive 4, so I'm subtracting 4 from both sides. So x minus 4 equals 0. And then taking these two terms, these two binomials, and multiplying. Using FOIL. So my first terms, x times x, gives me x squared. My outer terms, x times negative 4 is negative 4x. My inner terms, 4 times x is positive 4x. And then my last terms, going to be negative 16. So what happens here when we combine the terms in the middle? It's a negative 4x and a positive 4x. We are going to end up with a cancellation here. These cancel out. And we end up with x squared minus 16, which is what we would expect to get since our first term and our last term are perfect squares. This is the difference of squares type problem that we did in class. Okay? So just reversing what we did in class, starting with the roots and working toward the equation. Alright, and this is going to be your U-try problem for tonight. So you are going to fill out the table. This is your A and your B, so the first one has actually already been finished for you. The second one has been started. So whatever A and B are, you're going to start by adding them. And the next column, you multiply them, see what you get. And the last column, you're setting up two binomials. And then you're going to use FOIL to multiply the binomials and finally get standard form. Okay, so for the second one, it's already been started. Negative 4 and then 5. So we did negative 4 plus 5 to get 1. Negative 4 times 5 to get negative 20. So now the next one, you are setting up your two binomials. So it's going to be x minus a. So for this one, x minus a means it's going to be minus a negative. Okay, so minus negative 4, we'll change this to plus 4. And then x minus b, so x minus 5. And then you're going to FOIL it, just like we did in the examples. FOIL this to get the final form. Make sure you bring your completed work and notes to class tomorrow.